Let's discuss about the corrosion. Corrosion is a very important topic in the chemistry. When the surface of a metal changes from being an element into a compound, the surface goes from being shiny to dull, and this phenomena occurs in metal. Nearly all metals corrode. They do not all corrode at the same rate. Suggest a metal which does not corrode. If you see the electrochemical series, which is also known as the reactivity series, you will see that those metals which are at the top and in the middle, they can corrode, while those metals which are at the bottom of this series cannot corrode. For example, gold does not corrode. For the process of corrosion, we need three chemicals: air, salt and water. If there is the supply of the oxygen and water, then the process of the rusting will occur, and this process is speeded up in the presence of the salt. If you have only air and water, there will be corrosion, but at the slower rate. If there is no water and you have put some drying agent, then the metal will not corrode. If you have boiled water and placed the iron or some metal in it, then it will not corrode because there is no air. But if you have air, salt and water all together, then there will be a speeded process of the corrosion of metal. The corrosion of iron is called rusting. Iron is the only metal which rusts. Let's see the practical demo of the rusting. You see the water will rise up in the tube due to the capillary action, and here is a question: how would the rate of the water rising compare if the wool had been soaked in water instead of the acid? If there is the wool soaked in water, then of course there will be high rate of rising of the water. Now let's see the chemistry of rusting. Iron metal reacts with oxygen to produce iron 3 oxide, which is also known as ferric oxide, and this ferric oxide is called the rust. Now let's write the word equation and the chemical equation for this process. First is the word equation. Here iron reacts with oxygen to form iron 3 oxide, and in terms of symbols, our chemistry, we will write it. Iron is represented by Fe. It will take up the oxygen, and this process is oxidation, and it will convert into ferric oxide. This is an example of a redox reaction. Redox reaction is the one where reduction and oxidation both occurs simultaneously. Now I require you to write some ion electron equation of the following. In the first equation, you have to write the reaction of the sodium atoms when it loses electron to form sodium ion. And the second one, sulfur atom gains electron to become sulfidine. And third, copper 2 ion being reduced. When it accepts electron, of course it is reduced. So bromine atoms being reduced. Reduction is again accepting of the electron, so you can write Br plus 1 electron, arrow Br E negative 1, that is bromide. Chemistry of rusting. Corrosion occurs when metal lose electron, and this is known as the oxidation. When iron rusts, there are two steps. The iron is oxidized, and iron atoms into iron 2 ions are produced, or in the second step, iron 2 ions convert into iron 3 ions, that is ferrous ions are converted into ferric ions. So we can write the equation for both of them. Whenever there is oxidation, there must also be reduction. In the you can think of the other two chemicals which are involved in the rusting of the iron. These are oxygen and water. The reduction step involves these chemicals. water, oxygen, it takes 4 electrons to convert into hydroxyl ion. As the gain of electron is reduction, so this is the reduction process. Dissolved chemicals in the water called electrolytes help in the electron to be transferred. Ferroxyl indicator can be used to detect rusting. The chemical changes color in the presence of Fe+2 ions occur. It changes from yellow or green to blue. You can see this is yellowish green color of the ions, and these are converted into blue color. Ferrous ion convert into ferric. A chemical cell can be used to show electrons moving away from iron when it rusts. You see, this is the iron rod. When it loses two electrons, then it converts into Fe+2 ions. When it loses electron, then it is oxidized, and this process is known as oxidation. And the other side of the electrode, it gains electron, therefore it is reduction. Therefore we call that this process is the redox process. Reduction plus oxidation both occur simultaneously. Electrons leave the iron atoms when it rusts. Here are some more examples of the redox processes. Here we have iron and then we have tin. So if we have iron and tin together, then iron will rust and tin will not rust because of the difference in the position of their heights in the electrochemical series. Which metal in this cell loses electron? This is of course iron. Which metal is oxidized? And when this iron loses electron, it means it is oxidized. Describe what happens to the color of the solution around the iron. Around the iron, of course, the color changes due to the oxidation process. The mass of the iron in the cell is increased. Does the iron rust? Yes, iron rust. Here is the second example where we have magnesium and iron together, and as magnesium is more reactive than iron, so here magnesium loses electron and it is oxidized as compared to the iron. So which metal in this loses electron? This is magnesium, and magnesium is oxidized. What happens to the color of the solution around the iron? I think there is no change. The mass of the iron in the cell does not change considerably. No, iron does not rust here. How we can prevent the corrosion? There are different methods of prevention of the corrosion. We use the two types of the methods. One is the physical protection and other is the chemical protection. Physical protection stops oxygen and water coming into contact with the metal, and we can do this by using paint, oil or grease, plastic coating and tin plating. Tin plating is done where the iron is covered with the molten tin, and the next step is the galvanizing. Galvanizing is covering in the molten zinc. Here we cover the metal of the iron with the molten zinc, which is a quite expensive method. Then we can also use the cathodic protection method. Next method is the electroplating. Let's do the electroplating experiment. Here we have two metals, copper and gold. The metal to be coated is at the negative terminal. If we want to coat this metal copper with some other metal like gold, then we will make the copper as the negative terminal, and the positive ion of the other metal are in the solution. These ions are attracted to the negative terminal, and when they meet turn into atoms. So the copper is coated in gold atoms. You can write the equation for this one. Next method is the cathodic production method. When a metal corrodes, it dash electron. It loses electron. If electrons were forced back to the metal, it would not corrode. How could these be supplied? By connecting to the negative terminal of any electrical supply. This method is used in the cars. Next method is the sacrificial protection. A metal high in electrochemical series is connected to the metal to be protected and is sacrificed. It means more reactive metal. It is brought in connection with the metal which you want to protect. So this metal is corroded and the metal you want to protect is protected. This is used in underground pipes. Next method is galvanizing, where we coat this iron with the zinc solution.